Dear students, so in this class, we are going to learn about NQ problems. So NQ problem is one of the applications used by the backtracking method. So we already know the backtracking method. What are the applications of backtracking? NQ problem, subset of some problem, and graph coloring. Okay, these are the three applications we will see one by one. So now let's see about NQ problems. I think all of you know about played a chess game. Yes. So what did happen? Playing a chess game is also a backtracking algorithm. The idea is to place queen one by one in different columns. Start from the leftmost column. When we place a queen in column, we check for clashes with already placed queens. If the current column, if you find a row for which there is no clash, we mark this row and column as part of the solution. If we do not find such a row due to clashes, then we backtrack and return false. So NQ problem is to place n queens. Okay. For example, n equal to 1 means this problem has trivial solution. And n equal to 2 is 2 cross 2 matrix, that is chessboard, it has no solution. Okay. So next 4 cross 4 queen problem and 8 cross 8 queen problems. So NQ problem is to place n queens in such a manner on n cross n chessboard that no queens attack each other by being in the same row, column, or diagonal. Okay. So there is no queens can attack each other by being in the same row, column, or diagonal. That is the important point. Please remember this. Note the point. Okay. So let's see about how this NQ problem is works. So I said no. The NQ problems, if you have 8 chess queens, then it is 8 cross 8 queen problems. Okay, the chessboard is like a matrix, 8 cross 8 matrix. Okay, you have to place the queen. So where the queen be placed on the board? I set the condition. What are the condition? No two queens are attacking each other. Where? That is, two queens are not allowed in the same row. Okay, two queens are not allowed in the same row. That is, here we are placing a queen, and this row can't allow any queens. That is one condition. The next condition is or in the same column also. So if you are placing a queen here, then this column also you can't place any queen. Okay. And the next condition, diagonal. Okay. Along with the same diagonal. So once if you are placed the queen and this diagonal, you cannot place the queue. These are the three conditions. Please remember this condition. Okay. So depends on the conditions, we are using a backtracking method. We are finding the best possible solution. Okay, where to place the queues. So once if you are place the queue, the same row not allowed, same column not allowed, and the diagonal also not allowed. Okay, so the number of queues and the size of the board, it may be varies. I said no, it may be a 4x4 chessboard or 8x8 chessboard. Okay, so now let's see how to write the program for tries to find a way to place n queues on n cross n chessboard. Okay, so for that purpose, we are using that stack concept. Okay, so the stack means we have two operations. One is push, another one is pop-up operation. How to push? Push means what? We are insert an element. Pop means we are delete the element from the stack. Okay, the stack is works on first in first out manner. Okay, so the stack is used to keep track of where each queue is placed. Now let's see about it is 4x4 chessboard. Okay, so let us consider this is the first row, first column. Okay, so the first row, first column, as I place the queue. Okay, the first queue is placed in the first row, first column. So what happened that the next one, that rows, this row and sorry, this row and this column and this diagonal, we can't place the queue. Okay, so there is no possibility. So each time program decides to place the queue on the board, the position of the new queue is stored in record, which is placed in the stack. So first row, first column, as I place the queue. So these places I cannot place the queue. Okay. So next, the first row, first column is filled. So the integer variable can keep track of how many rows have been filled so far. Next, what happened that? So another one condition, each row or column, there is only one queue. Okay. So now we have to try to place a new queue in the next row. We start by placing the queue in the first column. That is row to column 1. So as per the condition, the queue cannot be placed here. So we are shifting to the next row, that is it is confliction. So we are shifting the queue into the next column. Okay, so second row, second column, it is also diagonal, so we cannot place the queue. So what happened that we are shifting the queue into the third column. Okay, because here confliction is occurred, so we are shifted right forward. So here there is no confliction, so 2 is filled. Okay, so row 2, column 3 is filled. So once if you are filled, what happened that again this row, this is the diagonal. Okay, for this one, this is the diagonal, this is the diagonal, and this is the diagonal. Okay, this is also diagonal, and this is the row, and this is the column. Okay, so what happened that third row we cannot fill any queues because For this one, it is occupied. For this one, this is occupied. For this one, this queue is occupied. So here it is occupied. So we cannot place any queue in this row. Okay. So we cannot able to solve this problem. Okay, when we are placing the queue in the first row, first column. So we have to go backtrack. Okay, have to go backtrack. So how? So that is backtracking method. So let's see about third row. Okay, the first portion we have a confliction. I said no, this row, this is the confliction. Again, it is the confliction. Again, it is the confliction. Again, the column 4 also confliction. We're trying to shift right forward again. Okay, so there is now we are moving back again. Okay, pop off the value from the stack and reduce it by 1 and continue working on the previous row. Previous row is this one. So now we are shifting this queue to the next column, that is fourth one. Okay, now what will happen? As I said, no. So for this one, we cannot find fill this one. We cannot fill this one and this diagonal and this diagonal, this row. For this one, this is the diagonal and these are the diagonals and this is the column and this is the row. Okay, we cannot place these places, so the empty place, this one and this one. Okay, so now let's see how it is happened that so 2 is filled, so the position is incremented by 1, so we have to move the third row. So again that third row, one that position is not possible, so again we are shifting to next one, then again we are starting at the second column. So finally we have the conclusion. We are tested that is initially you have to place the queue here, then this row there is no column, no queue, and column also no queue, column also no queue, and this diagonal also no queue. Okay, this is also diagonal no queue. So this is perfectly we are assigned. So the next column, next row, this is for this one, this is the only queue, and this row also this is the only queue, and diagonal also no queues. So it is also perfectly solved. And next row we have, this is the empty box, because here already we can't place the queue here also, here also. So we are placed the queue here. For this is the diagonal and this is the diagonal and this is the row and this is the column. So for this row and column and diagonal, we are perfectly matched, fixed the queue. Okay, and next to here only one place is available, so we are placed the queue here. So perfectly the 4x4 queue problem is solved. Okay, so this is 4x4 queue matrix. Okay, so the same way how to solve that 8x8 matrix. Okay, let's see in the next class how to solve the 8x4 8x8 matrix. Okay, the same concept. Okay, the row Once the queue is placed, the queue column, same column and same row cannot be placed the queue and diagonal also. Okay. And if it is a 4x4 matrix, each row, this row only one queue we have to place. So this row perfectly it is matched. This row only one queue, this row only one queue, this row only one queue. And column wise, this column only one queue, this column only one queue, this column only one queue, and this column also only one queue. And each queue when you are placing the diagonal also cannot place the queue. So for this one, this is the diagonal cannot be placed any queues. For this one, this is the diagonal. We are not placed any queues. For this one, this is the diagonal. And this is also diagonal. We are not placed any queues. For this queue, this is the diagonal. This is the diagonal. So we are not placed any queues. So this is the perfect solution. We are using the backtracking method. Place the queue in 4x4 chessboard.